Welcome to our second lesson, still looking at stoichiometry and more concept. In the first lesson, we discussed relative atomic mass as well as relative molecular mass. We also looked at calculating number of moles, 1 given the number of particles, 2 given the mass, 3 given the volume, and of course at a certain condition, that is calculating number of moles of the gas given the volume, and the conditions we have STP and RTP, that is room temperature and pressure, as well as standard temperature and pressure. We also looked at calculating number of moles from the equation, that is mole to mole ratio. In addition to that, we looked at finding mass, that is on the equations, that is mole to mass and mass to mass. So that is what we basically looked at in the first lesson. To build on that, in this lesson, we are going to look at limiting reagent. So we can start. So the first thing that we want to do is to define limiting reagent. So this is very important to understand even from the definition. Limiting reagent is just a reactant that finishes fast. That is one way you can define it. Or we can say it's a reactant that is in short supply by mole ratio, and hence it finishes before the other reactants are completely reacted. So limiting reagent is a reactant that is in short supply by mole ratio, and hence it finishes before the other reactants are completely reacted. So that is how we can define the limiting reagent. Now, without wasting much of the time, this is going to be, I think, the shortest lesson, because we have nothing much to discuss aside from just looking at how to if you are given a question, how to determine the limiting reagent. Okay, so I'm going to explain with a question, and this is an exam question that came in a particular year, and us going through this question, which means we are handling this part fully. Okay, so let us have a look at the question. So in an experiment to prepare a salt, Elena reacted 3.0 gram of magnesium oxide with 40 cubic centimeter of dilute nitric acid of concentration 2.0 mole per decimeter cubic. So that was the molality. The first question is, write the balanced chemical equation for this reaction. So on writing the balanced chemical equation, I have a lesson that I did on writing chemical equations as well as balancing them. You might want to go through that as well before going through this particular part. So let us write the balanced chemical equation. Now, remember the question that we are targeting here, find the limiting reagent, is at the end of this question. But of course, you cannot determine the limiting reagent without going through this part. So it all starts with writing the balanced equation, calculating the number of moles and all that. That is when you determine the limiting reagent, as we are going to see. Now, here the focus is just writing the balanced chemical equation. So, to write the balanced chemical equation, maybe I can even also seize this opportunity just to explain a bit on this particular part. So, to write the balanced chemical equation, the first thing you need to know what is reacting. So, in this case, we are saying in an experiment to prepare a salt, Elena reacted 3.0 gram of magnesium oxide. So, what is reacting is magnesium oxide. And you need to know the chemical formulae of magnesium oxide. So magnesium oxide is MgO. That is magnesium oxide. Okay, and this is a solid. Then react with. This plus means react with. Okay, then react with. Here you are saying dilute nitric acid. So dilute nitric acid. So here is reacting with nitric acid. It doesn't matter where they say dilute, but you need to know that it starts with nitric acid. So nitric acid is written as this. So this is the nitric acid. And of course, I emphasize that you need to know the strong acid. That is for strong acid, their names, and of course the chemical formula. That is, you have nitric acid, hydrochloric acid, sulfuric acid, and phosphoric acid. So these four, you need to know them for the sake of the exam. Okay, so what is going to form? Now, this is a base. Magnesium oxide is a base, and this is an acid. Generally, they react to produce a salt and water. So in this case, magnesium is going to displace the hydrogen there, and it is magnesium and nitrate that will be reacting. Nitrate has a valence of 1 as a radical, then magnesium 2. So you're going to have magnesium nitrate, and all these are explained in the video that I've just mentioned. So you are not going to have challenges if you go through that part. Then plus water at the end. Let me just try to reduce the size so that it can fit right here. So you're going to say magnesium oxide react with nitric acid. Okay, nitric acid. In this case, it is going to form magnesium as a salt, magnesium nitrate as a salt, then plus water. Okay, plus water, which is liquid. This is aqueous. This is aqueous. And this is the solid. So this is the equation. But the question is it balanced? So we need to balance the equation. So now let us check. How do you balance the equation? You know already that the equation that you write, the atoms on the reactant side, this side, the whole of it is called reactant. In the case of those that are coming across this for the first time, so this is the reactant side. Then of course we have the other side after the arrow, that is called the products. So what is found on the product is what you find on the reactant side. What you need to know is, what you need to do is to make sure that they are in equal ratio. So magnesium here we have 1, magnesium here we have 1. Look at this. How do I know that it's 1? You just look at the number in front. So in front here is 1. In front here is also 1. But oxygen, we can add this and this one. Okay, so we can add this one and this. So we have 4 oxygen. This side we have this one, and also this 2 multiplies everything inside. So which means we have 6 oxygen plus 1, we have 7. But this side we have only 4. Okay, then look at nitrogen. Nitrogen is also being multiplied by 2. So this side we have 2 nitrogen. This side we just have 1 nitrogen. So you can put a 2 in front there. And this 2 is going to multiply everything. It multiplies hydrogen. It multiplies, that is nitrogen. It multiplies oxygen. So in this case, 2 multiplied by, hydrogen is 2. Hydrogen is 2 this side. Then nitrogen is 2. Nitrogen is 2 also the other side. Oxygen this time around, 2 multiplied by 3, that is 6, plus 1, that is 7. So write just like this. The equation is what? Is balanced. So the equation is now balanced. Okay. So we've answered the first question fully. Let us have a look at the second question. Calculate the number of moles of magnesium oxide. So we are calculating number of moles of magnesium oxide. Now remember, from the equations that we've looked at, you need to look at the information that is given for magnesium. And to go back, here we are saying Elena reacted 3.0 gram of magnesium oxide, which means on magnesium oxide, what we are given is the mass, which is 3.0. Now they are saying calculate number of moles. What should link in your mind is that, what formula do we use when we are given number of moles? And you know surely that number of moles, if you are given mass, is equals to given mass over molar mass. In this case, the given mass is 3.0 gram. Divide, what is the molar mass of magnesium oxide? So what you have here is oxygen, which is 16, and magnesium. What is magnesium? So magnesium is 24. Okay, so 24 plus 16, that is just a 40. Okay, so I guess we've not missed it on the molecular formula. So 40 grams per mole. Now gram and gram cancel. Then we are going to have 3 divide 40, which is giving us 0.0775 moles of magnesium oxide. So that is what I found. And be able to confirm these numbers with your calculator as you go through this video. Then calculate the number of dilute, this is still the same question. Calculate the number of moles of dilute nitric acid. Now, if we are to go back again, we need to know the information that is given on nitric acid. So 40 cubic centimeter and concentration of this. So we are given the concentration and the volume. And therefore, to calculate number of moles, something should come to your mind, that number of moles is equals to, we are given concentration multiplied by what? Its volume. And remember what I said, the volume should always be in decimeter cubic. So we are given 40. What do? We say 40 centimeter cubic, of which this one, we say 1 decimeter cubic is equals to 1,000 centimeter cubic. Okay, centimeter cubic. So cubic centimeter and cubic centimeter cancels. Then 40, it will just be 40 decimeter cubic divide, that is 1,000. And this is going to give us 0.04 decimeter cubic. So that is what you are going to find as the volume. Concentration is given as 2. So 2 mole per decimeter cubic multiplied by 0.04 decimeter cubic. Decimeter and decimeter cancels. So we are going to remain with 2 moles multiplied by 0.04, which gives us 0.08 mole. So that is the number of moles of what? Nitric acid. And here I should have presented it this way, number of moles of nitric acid, like this, so that at the end you don't get confused which one is which. So like that. Even this one, you can present it like this, number of moles of magnesium oxide, in the bracket like that. Okay, so now we are done with calculating number of moles. The last question now that we are interested in is determine the limiting reagent. To determine the limiting reagent, one thing you should know is that limiting reagent, we said, is the one that is in short supply. Okay, and how do you find it? It is found by dividing the number of moles of the reactant by its stoichiometric coefficient in the balance equation. So you cannot determine the limiting reagent without the balance equation. So the balance equation is very important in as much as you want to find the limiting reagent. So we are going to go back to the balance equation and you just look at the reactant. So we are interested only in the reactant. So in other words, it's going to be number of moles of magnesium oxide. We are saying it is found by dividing the number of moles by stoichiometric coefficient. So what is the number of moles of magnesium oxide? 0.075 moles. Then we divide with the coefficient. Coefficient or stoichiometric coefficient, we are just looking at the number in front of magnesium oxide in the balanced equation. And there's a 1 there, so you divide it by 1. Then also we look at number of moles of nitric acid. Then also, what was the number of moles? 0.08 mole. Then now also we divide it with the stoichiometric coefficient in front, and in front of nitric acid there's a 2. So we divide this one by 2. And what are we going to have? 0.04 mole. And this one we are going to have 0.075 mole. Then now to determine the limiting reagent, you compare this and this. So the one with the smallest ratio or smaller ratio is the what? Is the limiting reagent. So the one with the smaller ratio is the limiting reagent. So if you are to compare 0.75 and 0.04, we find that 0.04 is smaller. And therefore here we can say nitric acid, which is HNO3, is the limiting reagent. So that is how you determine the limiting reagent. So these steps are the one that you follow. So sometimes you are given just find the limiting reagent or determine the limiting reagent. So the process is still the same. You need to have the balance equation. Then you need to find the number of moles of the reactants. Then you divide them by the coefficient in front of the balance equation. So if you've not done the equation well, which means the whole question you failed, you cannot determine the limiting reagent. Now, the other thing, as we go on in learning, we are going to come across things like calculating the percentage yield, also let me say calculating the mass of the products, in short the theoretical yield. Now how do you determine that? So it's very important to know this at this point, that the limiting reagent determines the extent to which the chemical reaction can proceed and the amount of products that will be formed. So let me just say that again. So limiting reagent determines the extent to which the chemical reaction can proceed and the amount of product that would be formed. Okay, so once the limiting reagent is finished, the reactant also stops. Now, what is the importance of this information? When calculating the amount of the product formed, you always form a ratio of the limiting reagent and that product that you are finding. So that is very important. When you are finding the amount of the product formed, you form the ratio of the limiting reagent from the reactants and also the product that you are calculating. As we've looked at the ratios, that is more to more ratio at some point and mass to more, okay, or mass to mass. So that is very important. All right, so that is what we needed to know about the limiting reagent, and therefore we've come to the end of the lesson. And if you are interested to join us for online lessons, also physical lessons, for online lessons you can contact the number 0976 402563. Okay, so for physical lessons we are found in Kabwata, near Kabwata Primary School. You can still contact the number for directions. Otherwise we can end here and see you in the next one.